our words, weathering, erosion, or deposition, goes with breakdown? Raise your hand if you know the vocab word that goes with breakdown. Weathering. Which word goes with dropped? When something gets dropped. Nope. Dropped.
Deposition.
Deposition. Dropped, deposition. I mixed it up, Sarah. I went out of order. Which one of our words, the only one left, goes with the moving or transporting of materials, John? Well, it is sediment that might get moved. So your choices are weathering, erosion, or deposition. Brooke? Erosion. Okay, good. So, weathering is the breakdown, and then it makes sense when things are in smaller pieces, it's easier for them to move, which is erosion. And then we know that things long-term cannot keep moving if the wind or the water slows down, or maybe if the glacier stops, then it is going to drop or deposit. So weathering, erosion, and deposition kind of makes sense that it goes in that order, okay? We have talked about, we've talked about the idea of how things get broken down with weathering. We are on erosion right now. So there are 5 agents of erosion. Humans are 1, and then we have 2 W's and 2 G's. What? Give me one.
Gravity.
Gravity is one of our G's. Good.
Wind.
Wind is one of our W's. Water. We have 9. Yes. Gravity, glaciers, wind, water, humans. Right? All right. So we talked about water. We've talked about, we're on the middle of talking about glaciers. All right. So on Friday, and I'm going to just kind of speed through this. We know that Ohio was once covered by glaciers. That video shows a good job of it being like the bulldozer. And the idea of plucking. We're going to watch a video I'm going to show at the end of this that kind of shows this very well. But remember, plucking, the word plucking to me always reminds me of like plucking feathers off a chicken, right? Plucking those feathers. Well, that's what the glacier is doing as it slides across the surface. It's able to pluck those pieces of rock. And then some of that rock gets embedded in the bottom of the glacier, and then it's able to like scratch or leave things called striations. And we'll talk about that a little bit more, I don't know if it's later today or tomorrow. The kind of generic name for the sediment that gets pushed in front of the glacier is our till. So if this is all the stuff that's getting pushed in front of the glacier, if this basket's my glacier, right, this is all the till. And then that till eventually is going to pile up at the edge, and then think about an ice cube melting, right? It starts to shrink. So as it shrinks, it almost looks like it's retreating or backing up. And as it backs up, it leaves the pile. There's not arms on the glacier to pull the till with it. So this pile of till that's left at the edge of the glacier is called a moraine, right? And so you can see that here. So this glacier I know is receding or melting, and when that happens, the moraine is formed by the till that was pushed out in front of the glacier. So remember how I said on Friday, think of it kind of like a story. If you think of the whole process, it helps put these words kind of in a natural kind of progression where it's not just like random words everywhere, but it's like, okay, first I know I have the glacier. It's plucking rock and dragging it with it. It's bulldozing and pushing the sediment in front, which we call till. When the glacier stops and actually starts to melt, it looks like it backs up. The till becomes moraine at the edge, and it gets left there. And then the glacier kind of backs up and leaves the moraine. Well, we know that a glacier melts. Ice turning to liquid makes water, liquid water, right? And so now you get these things called outwashes. It's the sediment that gets carried by the running water. So if you look here, this running water that's melting off of the glacier is going to cut right through my till, right through that moraine. And so as it runs through that, isn't it going to carry the sediment with it? Kind of makes sense, right? Running water is going to be able to carry material with it. And then eventually those temporary streams that are formed are going to dry up because the water source or the glacier is going to get far enough away where the water isn't really affecting it as much. And then if it doesn't have as much strength, as much force going with water flowing, that sediment can't be held anymore, and it's going to then get deposited or dropped. And so eskers form after the outwashes dry up, right? Because they're kind of like temporary streams, and we know streams kind of cut their way whichever direction they path of least resistance, basically. That's the way the water is going to flow. And so if the moraines, all the sediment that was in the moraines is being carried by the outwash, and the outwash dries up, it's going to just drop that sediment right where it landed, and it's going to have these S-shaped streams that are now dried up, and it's going to leave that sediment. And so you can see these mounds of weird shaped, I mean, it looks fake, and it's just because it was all the sediment that was being carried. Something kind of that can happen randomly throughout this process, if you have a glacier, sometimes big chunks, like if you've ever seen like a snowdrift that's kind of like hanging over and then a big chunk will fall off, same thing happens, but this is very, very heavy, very dense ice chunks, and so they leave big depressions, like big holes. Well, if you have a hole that's filled with ice, eventually that ice is probably going to melt, and when it does, it fills it in and makes these little lakes, and those are called kettles. The way I remember kettle is it kind of like a teapot kettle. It holds water, and it's usually kind of round shaped, and that's what these little temporary, sometimes they're permanent, but that's what these little lakes have formed. Yes?
Aren't those just ponds?
They are, but they were formed from a glacier. And they know that because there's other glacial evidence in the area. So obviously not all ponds and lakes are made from kettles or made from glaciers, and they're called kettles, but these are a special type of lake that are. I remember eskers because they kind of make S curves, because if you think of like a stream winding, that's what it is. It's a dried up stream, and so the S curve kind of looks like S curves. Okay, so again, trying to find little ways. I actually had a sophomore that I was talking to during homeroom, and he's like, "Oh my gosh, we have a biology test today over cells, and I'm afraid I'm going to not pass it. I can't remember all the different parts of the cell." And I was like, "Well, did you try to find ways like to make the words make sense, like to have connections with something?" He's like, "No." I was like, "Well, do you remember how like we always try to give like little cheats, little ways to try to remember the words, not just memorize them?" He's like, "Yeah." I was like, "Well, you have to do that. Like, you don't need the teacher to do that for you. You personally find ways, like connections with those words, and then it makes it so it's easier to remember." Right? So if you don't like my ways to remember it, find your own way, right? I just try to give you the ways that I use. Okay, so this is slide 30, and this is picking up with our first slide for today. Yes. All right, erratics. Have you ever heard of somebody driving erratically? Have you ever heard that term used? What does that mean? Does that mean that they're following all the safety laws and they're being very, very good driver?
No.
What does erratic mean in that sense?
They're driving crazy and recklessly.
Okay, so we're not saying that these rocks are crazy and like bad. What we mean by an erratic is something that shouldn't really fit there. So if there's some like 50 cars on the freeway, if only one of them is driving erratically, it stands out, right? It definitely seems like, okay, whoa, what is this car doing? Now, if it was like a Dukes of Hazzard kind of chase kind of thing, and like maybe like a dirt track race, or even like NASCAR, like all the drivers are kind of like, everybody's going fast, everybody's kind of, shooting around, that would be more normal. But if you're on a normal freeway and everybody's following the rules and there's one crazy driver, that driver's going to stand out. Same thing with these erratics. Hold on just one second. So an erratic is a rock that is totally different from the other rocks in the area. It might be different in size, it might be different in shape, might even be different in composition. meaning that this rock got carried from maybe hundreds or thousands of miles away with a glacier, and then as the glacier stopped, it left it as it retreated. As it started to melt, it couldn't carry that rock with it, and it just dropped it where it was. So an erratic is a very dramatic type of deposition, because that rock is now there where it doesn't fit with the surrounding environment. And so if you just, and sometimes people will move boulders like for decoration or landscaping, and so like we use them in that sense. But in nature, if you see a rock and nobody put it there, it's just there, it's probably been part of an erratic that was left from a glacier. Yeah, what were you gonna say?
NASCAR and stuff, aren't they still kind of uniform because they don't want to wreck and die?
They are, but I guess if you maybe had some, I get what you're saying. So erratics, it doesn't mean crazy or bad, it just means different or not kind of fitting in with what you would expect, okay? We would expect drivers on our freeways to all be staying in their lanes, going a pretty set speed limit. If you have somebody switching lanes and speeding up, slowing down, and just being crazy, they would be driving erratically. Same thing. You would expect all the rocks, all the things in the area to kind of look fairly similar or uniform, and then you have this random giant boulder. If you've ever been up to Mohican, there's quite a few of these around, because the Mohican is kind of the edge of where the glacier stopped. And so there is some evidence. Also up at Lake Erie, there's quite a few of these as well. Okay, so some glaciers are formed in high mountains, and we call these the valley glaciers. Those are the ones that we're more interested in than the continental glaciers like Antarctica. And again, we could have a whole unit on these valley glaciers, but mostly the temperatures stay cold enough up high in the summer where there's no melting of the snow. So year after year after year after year, the snow builds up, and eventually it's going to have so much mass, and the gravity is going to kind of start working on it and start pulling it downward. Right? And that video also showed pretty good how all that pressure caused the bottom of the glacier to kind of get melty and soft and squishy and kind of act as to help reduce the friction, and it gets that glacier to able to start to move, right? And so typically this is going to go from up high and it's going to work its way down lower. Makes sense. Okay, so here is a picture, kind of shows it well. It says it's a receding glacier, and I know that because look, they're calling this the moraine. So all of the till, all of the sediment that was being pushed in front of the glacier is now right here. That's as far as the glacier got. I know that because if it went further, that's where the moraine would be. Or if it didn't go that far, it'd be right here. But it's right here, so I know this is exactly where the glacier got, right? Now it's starting to melt, and as it melts, it looks like it's backing up. Obviously we know it's not putting it in reverse. That doesn't happen. But logically we know if you take an ice cube and it starts to melt, it looks like it shrinks, which means it looks like from one edge to another, it looks like it's shrinking in or backing up. And that's exactly what the glacier looks like. So some things from our vocabulary, right? Here's our moraine. This is the till that was pushed in front. We have the water that is melting off of the glacier. We call that the outwash. So look at these little kind of S-curved mini streams, right? As they cut through the moraine, they're going to take that till that was part of the moraine with it. If you would follow this further down, eventually that water, those little temporary outwash streams are going to dry up. When they dry up, they're going to form our eskers, right? And so this is one you can see that's even formed already. But all of these, as long as they have sediment in them, when they dry out, that sediment's just going to drop right there. And if it's left undisturbed, you're going to have these weird mounds in that S kind of curved shape. Here are some kettles. So if the glacier was here, it makes sense that if a chunk would fall, it would kind of fall forward. And so it's left some of these kettles, and they are full of ice. And then when that ice melts, now they're full of water, and they form a pond or a lake. Okay, So again, I said if you kind of think of this as a story, or don't think of the words in isolation, it kind of helps to put it together and help to remember those. Okay, so we are going to watch some videos a little bit more on the glaciers in a minute, but we have talked about water, we have talked about glaciers, so now we're going to talk about wind, right, as our agent of erosion. Oh, and we've talked about humans. So just like sediments being carried by fast-moving water, sediments can be carried by wind as well. Who here's seen Forrest Gump? All right, the very opening scene that goes on forever, like when he's sitting on the bench and you hear that, like the theme song playing, and there's a leaf, right? Isn't it like blowing for forever? Like it's just kind of fluttering in the breeze. When that wind dies down, the leaf starts to land, and then the wind picks up and it picks that leaf up again, right? And that's what I always picture when I think of something moving fast or something moving slow. When it's moving fast, it can hold something, whether it's a leaf, a stick, sediment, whatever it may be. When that wind or water dies down and the speed slows, it drops it or deposits it. That's like what happens when the water flows out of a river into a ocean or into a bigger body of water, and that's why we get deltas or all that sediment where that speed change. Wind will work the exact same way. Sometimes it's almost easier to see it with the wind because it's right there, it's not under the water where sometimes you can't see that deposition happening. So the faster the wind blows, the more sediment it can carry. And so as soon as the speed changes, then the amount of sediment it's carrying changes as well. So if it slows down, then it's probably gonna drop some or everything. Yes?
Isn't this like what tornadoes do or something like that?
Well, yeah, because they have high moving winds, so they could carry a lot, right? And they cause a lot of destruction. And so the process of carrying that material would be a type of erosion. And then the dropping of it is that deposition, right? And so if you think about that leaf, that's a real good visual. All right, so this bottle, I've been keeping still. It's been like this since last year. I have some sand, some silt, some clay, some little pieces of gravel, little pebbles. You can also see even like at the very top, a little bit of like, looks like mulch or like branch, pieces of trees or something, little pieces of wood floating around. But the water itself, and I'm trying to be very still so I don't agitate it too much. The water at the top is pretty clear, right? I mean, it wouldn't kill you. But no, you're not going to drink my bottle.
Dang.
My science bottle of water, my science.
You're not even allowed to drink in a lab.
Yeah.
It's not a lab, it's nose.
Okay, so you can see it's very, very separated out. Okay? And I'll walk around again so you can maybe see a little bit from the top. And again, it's starting to get a little bit murky if you look from the top, just because I've been walking around with it.
I shake it.
No.
That's cool.
So, looking at it from the top, you can see those pebbles. So the reason I've kept it so still for all these months is because I want it to be pretty dramatic, right? I want that to be, it's had no motion until just now, right? And so everything is settled out. The water is not really carrying or holding anything. It's all at the bottom of the bottle here because it has, nothing is caused it to move. But I know, as soon as I add some motion or energy to it, it mixes it all up. Adriana looks horrified. Okay? As soon as I stop, the heavier stuff goes to the bottom. And you can kind of see those bigger chunks at the bottom. Right? I see, and if I tip it this way, you can see it even more. Right? All that heavy stuff is at the bottom. Now, the tiny little pieces are still mixed in. It looks like chocolate milk, right? But if I leave this, and I will leave this bottle out and we'll kind of see, it takes a while, but those fine pieces of sediment will settle out eventually, leaving that fairly clear water that Zach wanted to drink. So this is the same water, yeah, right? So again,
Make pain go away.
as I shake this around, I can feel the chunks moving, I can feel those rocks moving. I can also hear it. As soon as I change the speed and slow it down, it's not carrying that big stuff anymore. Now, the fine stuff still is being suspended or held in that liquid, okay? Yes,
Can we shake it so we can feel the sharp?
at the end you can, yes.
How did you get to stay like that for a whole year?
So I have it in my cabinet, like after we're done looking at it, I'll put it back in there and then it just stays. Cause if I leave it out, then every once in a while someone's like, can I please just shake it? And so I wanted to show you that, but that's a good visual. As soon as there's not enough speed, it has to drop the big stuff. The fine stuff doesn't take as much energy, so it's still being held there, even though there's not a whole lot of motion. Okay, so abrasion, and this was true, we introduced this with the idea of plucking, right? So the glacier, the bottom of the glacier is able to pluck or pull some of the bedrock, the chunks, and then it's able to take those chunks and they're embedded in the bottom, so they are part of the glacier now. And so they are going to be able to scratch. This is actually a type of physical weathering, where rocks and other items are like grinding or rubbing past each other. Think of kind of like sandpaper, right? It's able to change the surface a little because it's able to take off some of it. So you're actually breaking that down a little bit. And it's just happening basically at the surface level, but it's still breaking down that bigger rock and making it a little bit smaller. The abrasions or the scratches caused by the rocks that were plucked can cause big gouges. It looks like big, like claw marks almost. And we'll take a picture or look at an example of that here in a minute. But wind can also carry sediment. If you've ever been like on a baseball field or at the beach, if it's real windy, sometimes you could feel like the little pieces of sand hitting into your legs or hitting into your arms. And sand over time that's being blown with heavy winds can cause a lot of really dramatic features. Yes?
I've ate sand, does that count as deposition?
You have what?
I've eaten sand.
No. All right, so the wind can cause some really cool things. Has anybody ever seen sandblasting done?
Yes.
This is Santa.
You what? Sandblasting is sometimes how like before they get a vehicle or something that they're getting ready to paint, they will sandblast it up. It's almost like high pressured sand coming out, and it's meant, instead of having to like take sandpaper and like hand sand it, sandblasting is a lot quicker and it's a lot more effective and not more intense. And then they'll get the surface ready and prepped and then paint it after they've sandblasted it. But nature will do this as well. And so if you have like a set of rocks or like this big rock formation, the sand is going to wear away at the softest part of the rock first. So whatever is left is obviously the more durable, hardier rock. And so we get left with these really cool looking odd formations. Yes?
Sanding with like hand sanding or using automatic, sandpaper is easier than not easier, but smoother than sandblasting.
It would be, and you might have to, you're gonna need to do that in between classes from now, but I will let you today. But from now on, go in between class, okay? So you cannot miss out on this. Yes, and I agree with that, but both of them are effective at getting that surface prepped, and then you might have to come back with, touch it up with a hand. So again, you can see like it looks like you can almost visualize like the wind whipping around this rock, or this sometimes canyon or cliff or something, and causing that to happen.
So smooth.
Water can also do this, as the rocks are rubbed back and forth. Think of the tides pulling in and coming out, pulling in, coming out. Those rocks are tumbled and tumbled and tumbled, and even like the pebbles that are in my bottle are that way. Not from what I've done, but from, like that's just how they were. So when these were when these were younger rocks, they probably had some edge to them, but now they've been, constantly all day long, like rolled and tumbled and rolled and tumbled, and they just kind of wear all the edges off. Yes?
Those look like they'd hurt, like stepping on them. Have you ever
Maybe.
stepped on a marble?
Yeah, but if you're standing on all marbles, it wouldn't. If you just have a single one, yeah. But because they're all there,
Yeah,
Probably
but
wouldn't
the
be
green
bad.
one, stepping on that green one hurts more up than all the other ones.
okay. Glacier movement can also cause rocks plucked from the ground to grind over new surfaces, and so, I'll show you. We'll get to some pictures of that. So here's another picture. So here you have the glacier, it's moving, right? And so as it's moving down this area, it's able to pluck some of the pieces of rock from the bottom, and it's able to pull them. And then it's saying that this is the end of the glacier, and that's where that till is kind of stopping. Yes?
In theory, shouldn't that now melt? Because it can't move anymore? Because how steep that angle is?
Well, maybe it depends on how much force it has. But I'm going along with that because it does say that that's the end. So yeah, it probably will start to melt. Okay, and so this rock just kind of keeps cutting this, making it deeper and deeper, kind of hollows that out. Here are some examples of striations. So you can see, we know the glacier is definitely probably moving this way or this way, because that's the way that the striations are. You can see fine ones here, you can see really big ones. So it went through a really rocky area, and it was able to pluck a lot of rocks up, and so now it's pulling those. It has all the force and mass of that glacier on top of it, so it's really able to push them in there and just grind them through that flat rock that was on the surface. So abrasion can happen from the glaciers, it can happen through just water, and it can also happen through wind. And they all cause them to kind of act like sandpaper and physically weather the rock. So you think, like weathering, it makes sense that things get broken down and then it's easier to transport. During that transport or erosion process, though, it can also cause more physical weathering. So these are kind of cyclic, where like they are in a cycle where, you have weathering, erosion, and deposition, but then you have erosion causing more weathering, and then the weathering causes more erosion, and so it kind of is just like this never-ending process. And so the physical weathering wouldn't be possible, though, without the movement or that erosion happening. So, and the erosion wouldn't be possible if there hadn't been some weathering that breaks the material down into smaller pieces. So again, they all kind of depend on each other. And then nothing would ever get deposited if nothing was ever moved from erosion. So again, it's a very related, very tight-knit relationship between the weathering, erosion, and deposition processes. Okay, and so if you've ever been to the ocean, or even like up at like Lake Michigan has a lot of these, they're called sand dunes, right? Has anybody seen sand dunes or, okay, guess what we have seen, the other version of this, here in Ohio. Snowdrifts basically react the same way as sand dunes. It's tiny little pieces of stuff, whether it's sand or whether it's snow, and it's going to get blown by the wind. Well, we just had this over Christmas, right? We had those 3 days where we had all that blowing and drifting. There were drifts out by my house that were on both sides of the road, like they were able to just barely plow it enough. And we have a big dually truck, and it was higher than the roof, like the ceiling of our truck. And it was like you were driving through a tunnel of snow. Yes.
You should have went through the drifts in the truck. It would have been awesome.
Yeah, you would have gotten like 1 foot in, and that was about it. So no, that wouldn't have been a good option. So the way we have firsthand knowledge of how this happens, right here with snow, same process happens with sand, okay? If there's anything that is, in the path, okay, Zach, why don't you move over here to Haley's, to that table over there, okay? So anything that is in the path of the wind is going to kind of act as an obstacle. So whether it's a rock, a clump of grass, whether it's, we actually put up fences, like where we know the wind blows, like on 19, before you get, well, if you're leaving school, you pass Candlewood, before you get to the S-curve on 19, there's usually that orange snow fence, and the reason they put that there is because the wind blows across 19 right there. And so they put that fence there so that the snow will hit that and stop it and drift it there instead of it drifting on the road. Because a lot of times when it hits the road or the ditch by the road, it will drift right there. And so you'll see that in a lot of fields, like the farmers know, even the counties and the townships know. And so sometimes they will put up that snow fence, and it just gives them a lot less that they have to worry about because they know, hey, at least they're blocking that part. Because most of the time, like I know like around our house, we know right where it's gonna drift because usually the wind is coming from the same direction. So unless the wind changes, it's pretty predictable where those drifts are gonna be. I can tell you, like out front of my house, there's two spots, one right before it and one right after where it always drifts. And it's just the way, because the way the ditch is and the wind hits and then it drops that snow right there, right? So, same thing if you've ever been to the beach, sometimes they will want to kind of have natural dunes and they will plant like little shrub grass, and so that it will catch that sand and block it for whatever reason, like for a walkway or to help build up an area. So we can use what we know to help cause like natural barriers if we want them or need them for a certain place. And so again, here in Ohio, we have snow drifts, and see how it's catching right on this fence? It's not that the snow can't actually get through it, but it slows it down, and so then a little bit of snow piles up, and then more snow hits that pile, and then it piles up more and more and more. Okay. Okay. So let's go ahead, we're gonna stop there.